Now let's learn to compare fractions. Just like comparing any two normal numbers, what do? We take the numbers, we represent it on number line, and then we see whether it is far away from zero or very near from zero, and things like that, and then we compare the numbers, correct? So if you have to compare the 1 and the 2, 1 and the 3, you will see that 3 is much on the right. Whichever is on the right will be greater compared to whatever is on the left, right? Whatever is on the right will be greater than whatever is on the left. This is a common principle that we apply to compare any two numbers. That's the same principle that we will follow even for comparing two rational numbers. Right? Now, if I say two rational numbers are there, one of it is a positive rational number, the other one is a negative rational number. See, for example, 2 third and minus 11 over 5. Okay. If you see, yeah, of course, 11 and 5 greater in value compared to 2 and 3 and all. But just because all the negative numbers, let it be negative integers or negative rational numbers, everything is going to be on the left side, correct? So, therefore, the left or this is going to be in the far left compared to this number. So, the number that will be there, the right side of the zero, that is a positive rational number, that will be greater than the negative rational number. As simple as that. You don't have to do anything more than that to compare a positive and a negative rational number. Now, if you take the case of a positive rational number and a positive rational number, let's say like a positive and a positive rational number. Let's say again 2 over 3 and 11 over 5. 11 over 5. Okay, now this is just like comparing any fractions. When you were comparing any two fractions, what we used to do, we used to take the least common multiple and make this both the fractions having the common denominator, same denominator, right? So here we have to multiply by a 5, here we multiply by a 3, so that our denominators become same. That is, this will transform to become a 15 in the bottom. Again, this also will become a 15, right? This will become 3 5s are 15 and 5 3s are 15, correct? And this will become a 10 and this will become a 33. With this, we know both the denominators are the same and this is going to be greater. That means what? Any two rational numbers you take, it is just like comparing any two fractions. Let the denominators be same. If they are same, directly you compare. If the denominators are not same, you're going to change both the denominators into a common denominator and then compare. Finish. Right? Now, if we take a um, positive integer, positive rational number and a negative rational number now. Positive rational number, sorry, negative and negative. Sorry, negative and negative if we take, what happens? Let's take again negative 2 over 3 and a negative 11 over 5. Same kind of a thing. Both are negative. Now, how do we compare this? Again, same. First of all, we have to, because the denominators are different, we are going to convert that a common denominator, correct? Then, as we did last time, we were going to get negative 33, sorry, negative 33 by 15, because we want to multiply by 3, and here we're going to multiply by 5. So what will happen? It will be a negative 10 over a 15. Now we have to compare these two things. When we are comparing these two things, we'll have to understand that how we were how we were plotting, how we were marking the rational numbers. That means from here we were seeing where the 10 over 15 will come, correct? That means 10 over 15 will come somewhere here, correct? Somewhere here, negative 10 over 15. Because from 0, the position of 10 will be nearer compared to a position of a negative 33 over 15. That means, remember that you start counting from the 0 and going to the left. So, when you go to the left, negative 10 will come first. Then later on, the negative 33 will come. So from this, you can, in your mind's eye, you can see that the 10 will be very closer to 0 and negative 33 over 15 will be little farther. That means to say negative 10 over 15 will be to the right and negative 33 over 15 will be to the left. And using the same principle, the right, whichever is in the right, will be greater in value. So we take this one and this becomes greater in value. Correct? It's the same principle always. Right side number will always be greater than the left side number. And if we can visually think and see where negative 10 will come, negative 10 over 15 compared to where negative 3 33 over 15, you will know that 10 will be little nearer to the 0, thereby it is on the right side. Negative 33 will be a little farther from 0, and that's why it will be from the on the left side. If we are comparing a positive 10 over 15 and a 33 over 15, what will happen? You will start counting from the 0. No? So the first 10 over 15 will come nearer to 0, and the 33 over 15 will come farther than the 0. Correct? Farther than the 0. Now, if that be the same thing, now whichever is to the right, that will be greater. Correct? That will be greater, and because of that, 33 over 15 will be greater. This way, you can compare any two rational numbers. We have seen the case of positive, negative, positive, positive, and negative, negative. These are the only three possibilities of comparing rational numbers. Now, let's try to find rational numbers between two rational numbers. Okay. For that, let me take from the example of positive rational numbers and go on to explain how negative rational numbers also you can find. Now, is 0 and 1 rational numbers? Yes, they are, because 0 could be represented as 0 over 1 and 1 could be represented 1 over 1. Both of this being having integers and the denominator is not a 0, then this is a rational number. Correct? So, now if we want to get, say, for example, if you want to plot um, 3 over 13 and 10 over 13. Okay. If we want to plot that, we know that what is the first thing we have to do? We have to cut all the, let me write it a little farther away. This is 0 over 1. We know that we have to cut this entire distance from 0 and 1 into 13 parts. Correct? 13 parts we are going to do. 13 parts we are going to do, and this is not this is not to scale, not correctly for 13. So basically when we do this, we will know that 3 over 13 will come somewhere here and 10 over 13 will come somewhere here. Now, the question is to find rational numbers between them. We can clearly see that simple, if you just have to find 2, 3 rational numbers, it's easy. After 3 over 13, what is the next one? 4 over 13. Next, 5 13th. Next, 6 13th. Correct? It will be very easy for you to find like that. That's very simple. Correct? Because there is something called 4, 5, 6, 7, 8, 9, and all between the 3 and the 10. So all those rational numbers from 4 over 13 to 9 over 13, all of these things can be in between. If it is both the things are common denominators and the numerators are a little farther away, can all the numbers between 3 and 10 can come in the numerator and those rational numbers will be in between. Now, what if my question was to find rational numbers between 3 over 13 and 4 13th? Now I'll say 3 13th and 4 13th. We'll say 3 and 4 are next to each other. Next to each other. Correct? If you tell like that, let's think that this was a 3 over 13 and this is a 4 over 13. And then you might say that there's no rational numbers between these two. Let me tell you something, that this 3 over 13 represents this point and 4 over 13 represents this point. Now, are you saying that there's no dots or points between them at all? No, that's not the case. See, you have all these points here. So every point on the number line should have a number representing it. So as such, if we find out what are those numbers, then we can find. For that, a simple trick is, if you want to find, say, two, one rational number between them. Say between 3 and 4, if you want some number, what will you do? Whatever space is in between 3 and 4, you will cut it. And that will become three and a half, isn't it? Or if you write it in a improper fraction, that will become a 3, 3, 1, 3.5 will become a 7 over 2. It's same. So just by cutting it in two parts, you were able to get one rational number between these two, 3 and 4. Correct? Just like that, if you want, say, three rational numbers, you just have to cut it into four parts. Correct? So you just have to increase this denominator, the number of parts you have to increase. So let's say I'm going to increase it by four times. I'm going to increase. If I'm doing for the denominator, I have to do for the numerator as well. In this way, I am not changing their value. This becomes 12 over 52. The 4 over 13, that will change to 16 over 52. Right? Now I got what? I got same denominator. Now between 12 and 16, do I have numbers? Yes. What are the numbers? 13 or 13, 14, 15, right? 13, 14, 15. I got that. So 13 over 52, 14 over 52, and 15 over 52. All these are the numbers that I wanted. Like I wanted three rational numbers between the 3/13th and 4/13th. What is secret? I just increase the number of parts by getting equivalent fractions. If I want three rational numbers, I can just multiply by 4, one extra. Right? So one extra, you just have to multiply. So you can convert that into a different equivalent fraction. And between that, whatever numbers are coming, whatever fractions are coming, you can represent and show that's the number of fractions you get. Now, if you ask, how do we do for this same thing for negative between negative fractions? That's the same way. It is just that on the negative side of the number line, it's going to be there, right? It's just that if it's a negative thing, everything becomes a negative thing. So between negative 12 and negative 16, between, for example, if you say negative 12 is here, then if negative 16 is here, surely a negative 13, a negative 14, a negative 15, all are going to be there between them. So between, let it be for positive rational numbers or negative rational numbers, it doesn't matter. You just have a extra negative sign coming in between. So what's the technique? What's the trick to find out number of rational a different number of rational numbers? For example, if you need six rational numbers between two numbers, you can multiply this numerator and denominator by seven, the next number. So surely you're going to get that many parts. Surely that's the trick that I am giving you. You can use it. So now we're done with. Now, coming to operations means addition of rational numbers. Operation means addition, subtraction, multiplication, division, all of those things. Addition, subtraction, and multiplication and division. Now, all of this is simple that if you understand rational numbers are fractions with having negative numbers also coming in the numerator and denominator. If you know fraction addition, you know rational number addition. If you know fraction multiplication, you know rational number multiplication. It's simple as that. Just that now if you're having negative 3 over 16 and 11 over 16, now you're going to add them. So both are rational numbers, you're going to add them. How you used to do in fraction? If the denominators are same, you used to just add the numerators. Here, negative 3 and 11 has to be added. So you have to know how integers work. Negative 3 and 11, if you add, you're going to get a positive 8. Correct? Just that 16. 8 over 16. That is it. So you have to know how integer addition, subtraction, multiplication, division works. and you have to know how fraction, addition, subtraction, multiplication, division works. And the same two principles, you're going to use it here. Nothing more extra steps are required. Okay. So now if you're saying subtraction, negative 3 over 16 minus 11 over 16, what do? We know that if it's negative here, it gets attached to this number here. So it's a negative 3 and a negative 11 becomes two negative integers. Two negative integers, how do they work? We have to finally add them. That becomes a negative 33 over 16. Now, if we take multiplication, okay, if we take multiplication, for the same numbers. How does multiplication work? Works by multiplying the numerators and multiplying the denominators, right? So you want to multiply the numerator and denominator, and the denominators also you want to multiply and write. If you're going to go division for two numbers, what is the way you do for fraction? You take the second number, the second rational numbers, reciprocal you take and multiply it. So this is like getting it like this and getting the rational numbers reciprocal. So 16 over 11. And later on you do the calculation and you get a 3 over 11. So this is the way you do division. That means what? You just have to include both the concepts of integers as well as the fractions. With that, you can deal with all kinds of operations in a rational number situation. Rational numbers are nothing but fractions, but the extra thing is it can have negative numerators or negative denominators also. So you have to know how a positive number and a positive number, how they add up, how a positive number and negative number, how they add up, or when they multiply, what happens. These two concepts, if you know, and integer, if you know, and fraction, if you know, then you can do all the operations on rational numbers. It's going to be easy. I hope this was easy for you too. See you again in the next video.